Okay, let's go ahead and get started. So, last time I asked y'all to take a look at the review to see if there's anything you're having trouble with. So, y'all have anything you want to go over before we just go over the review? No? Alright. Let's just get into the review then. So I have a version of the review that I've made here that is all the same questions, just I've changed around some of the values. But it's exactly what you can expect to see on your review and the test. So, number 1, determine whether the statement describes a population or a sample. And it gives us the high school GPAs of all employees at a textbook company. So is this a population or a sample? Population. What's the key word here? All, yeah. So since we're talking about all of the members of a particular group, this is a population. If we were just looking at a selection of the people in this group, then it would just be a sample. Very good. Number 2, in a blank experiment, neither the subject nor those conducting the experiment know whether the subject is in the control group or the treatment group. Is this a single blind or a double blind experiment? Double blind, absolutely. So in a double blind, no one knows who's in what group. In a single blind, who knows the positions of the group? Yeah, so the researcher or whoever's conducting the experiment, they're the one who knows, and that would be a single blind. Okay. Number 3, Determine whether an observational or experimental study is appropriate to address the following statement. It says, a general manager of a restaurant wants to find out her average daily receipts. So is that an observational or experimental study? Observational. Yeah. So all she's doing is she's just collecting the receipts and getting the data from that. To be an experimental study, she would have to actively change something that would affect how the data comes out. And so she's not really changing anything, she's just looking at what the receipts look like. Okay, number 4. A physics instructor wants to determine if taking a calculus course before taking his physics course improves students' grades in the physics course. The average class grade would be considered the, response variable or explanatory variable? Any ideas?
It would be a response.
It'd be a response, good, yeah. So an explanatory variable is one which can explain the phenomena that's going on that's influencing the data. So the explanatory variable here would be that taking the calculus course before taking the physics course improves grades. But that's not what we have. We just have the average class grade. So the average class grade is a response to taking the course or not. Any questions? Okay. Next. So it says a mid-sized mobile carrier keeps records of complaints received from its customers. Complaints for last month are listed in the following table. What percent of the complaints are due to the category incorrect billing? Round your answer to 2 decimal places if necessary. So what it gives us is a frequency table. So all of these categories are assigned a certain frequency, but the category that we want to know is incorrect billing. This one right here. And we want to know what percent this is of the overall complaints that they've received this past month. So how would we go about doing this? Any ideas?
Add them all up.
Okay, yeah. So first of all, if this is supposed to be a part out of the entire thing, we need to know the total. We need to know what all these are if we add them. So go ahead and do that. We got 118, 118 plus 99 plus 87 plus 92 plus 106 plus 89 plus 43 plus 156. That gives us 790. So now what are we going to do with these two numbers? We have 89 and 790. Divide which one by which one?
Divide 790 by 89.
Other way.
Oh, yeah, okay.
Yeah, so remember that a percent is always a part out of the entire thing. So a percent is always out of 100, you know? So the same thing with this. We want to take this part and make it out of the whole. So we can go ahead and divide this and get our decimal representation, and then we need to convert that into a percent. So 89 divided by 790 is 0.1126.5. Okay? Now this isn't a percent, this is just a decimal. So what do we need to do to make this a percent? Okay, so remember it's out of 100. How many zeros does 100 have on it? That's the number of places. So we move it 2 places, and we get 11 point, let's see, we need to round this to 2 decimal places, so 11.2 what? 7. There's another way you can look at this. Again, get your total and make it a part out of the total, so 89 out of 790. And then say this is the same thing as having some percent out of 100. So what you do then is you multiply the numbers that are across from each other, and we get 8,900, and then divide it by 790, and it will give you directly 11.27. Okay, both of those, they're doing the same thing, just in a different way. Any questions? None? All right. Next, consider the following data. So it gives us a set of data here, and then asks us to determine the mean, median, and mode if there is a mode. So what's the first thing that we should do here? Put them in order, absolutely. So if we go put it in order, it's -14, -3, 0, 3, 12, and 14. Okay, so let's tackle the mean. What do we do to get the mean? Yep. So let's go ahead and do that. So add them all up. -14 plus -3 plus 0 plus 3 plus 12 plus 14 comes up to 12. So how many data points do we have? 6. So 12 divided by 6 is what? 2. Okay. Now we want to find the median. So it's the middle number. So what do we have in the middle of our data here? Now we have two numbers in the middle here, 0 and 3. So what do we do to find the number between them? Add them and divide by 2. So 0 plus 3 is 3. 3 divided by 2 is 1.5. So there's our median. Excellent. And what's our mode? No mode. Perfect. In order for us to have a mode here, we would need a number that is repeated more than any of the others. Well, all of them are listed once, so there's no mode. Excellent. Any questions? All right. Next, calculate the GPA of a student with the following grades. A for a 17-hour course, B for an 11-hour course, and C for another 11-hour course. And then it says that A is a 4.0, B is a 3.0, C is a 2.0, D is a 1.0, and F is a 0. And it wants us to round our answer to 2 decimal places. So, how should we start this one? It's kind of hard to see. How should we start this one? Okay, so remember that this is a weighted mean. A GPA is a weighted mean. So we have weights and values. Now what do we need to do between the weight and the value? Add, subtract, multiply, divide. Okay. So for each of these, we have a weight and a value. So 17 hours, and A is equivalent to 4. What we want to do is we want to multiply the value by the weight. Okay? So just like if we had literal weights in real life, like a 1 pound weight, that weight is the weight, how much it actually is worth. Then the value would be how many of those weights we have. So like if we had 6 1 pound weights, how much do we have in total? 6 pounds. So it's multiplying. So we want to multiply 4 times 17, 2 times 11, I'm sorry, 3 times 11, and 2 times 11. Okay, so 4 times 17 is 68. Then 3 times 11 is 33. And 2 times 11 is 22. And we want to know the total that we got for all of those. Okay, so again, what we're doing is we're adding up how much weight we have collectively. Now, what we want to do here is to divide this by the total that was available. So we had 17, 11, and 11. And so now we just need to calculate this. Any questions so far? Making sense? Okay. So again, we need to add these up and divide. So 68 plus 33 plus 22 should give us 123. And then 17 plus 11 plus 11, it's 39. Okay, so now we just need to divide. So 123 divided by 39, we get 3.15. And so there's our overall GPA. So it's points earned versus points available. And the points earned is, of course, multiplied by a weight. Any questions? Okay. Next. For the graph shown, determine which letter represents the mean, the median, and the mode. Letters may be used more than once. Okay. So remember that what these type of graphs show is frequency. So as we go along here, we have numbers, you know, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is just a number line here. And then the height of this graph shows the frequency of that number. So how frequent is it? So if we look at A, this is a peak, the highest peak in this graph. And so if we have a number that is occurring more than any other number, what do we call that? Mode. So mode is A. Okay. Directly next to it is B, and this is between A and C. You can kind of use this to remember that this is the middle of our data. It doesn't look like it physically, but if we were to think about it, there's a whole lot of numbers on this side of B. There's not a whole lot of numbers on this side of B. This is the middle. Okay, so this is where the middle of our data is. So what would that be? Median or mean? Median. Yeah, it's the middle. And then C is the mean. It's the one that's always on the other side of the median from the mode. So, C. Any questions? All right. Next, consider the following data. So it gives us another set of data, and it wants us to calculate the value of the sample variance, the sample standard deviation, and the range. Okay, so two things. One, it's a sample. We need to keep that in mind. We need to calculate this as a sample. Now, I believe on your version of the review, I took variance off because I don't think I'm going to test for that, but I do want to go over it. Okay, variance, you calculate it when you calculate standard deviation. Okay, so our formula for standard deviation of a sample is S equals the square root of the sum of x minus x bar squared all over n minus 1. Okay, so variance is everything underneath that square root. Once you do that, you have your variance. Then once you take the square root, you have your standard deviation. Okay, another word for variance is standard deviation squared. Okay? So we need to know x bar and n. What does x bar mean? Yeah, mean. X bar is the mean specifically of a sample. If we instead had a population, what would that symbol be? Instead of x bar, that symbol would be what? Mu. So for a population, it's mu. Now it doesn't really matter because sample population and sample of a population, what am I saying? Mean of a population and mean of a sample are calculated the same way, but we have specific symbols for them so that we understand that we're talking about either a sample or a population. Does that make sense? Okay. Now what is different about samples and populations is standard deviation and variance. So this right here is a sample. What would be different about this formula if it was a population? X bar would instead be mu. Yeah, that's one thing. There's one more big thing that's different for population standard deviation. We would not have -1, yeah. So remember, we have to account for the fact that we're talking about a sample when we're doing our standard deviation. That's why we subtract 1. With a population, we have the entire n. So we don't need that -1. And of course, n is the number of data points we have. So how many data points do we have? What is our n? 6. Now let's find our x bar, our sample mean. So we need to add all these up. So let's see, -6 plus -4 plus -9 plus -4 plus -4 plus 9 is 36. And divide that by our n, so what do we get? 6. Now, it's -36. So -36 divided by 6 is -6. Yeah, so our sample mean is -6. Okay. So now we can go ahead and do our formula here. First thing we need to do is x minus x bar. So take each of these values and subtract the sample mean. Okay, so if we do that, like this first one, -6 minus the sample mean is -6. What happens here with these two negatives? Cancels out and becomes what? Positive. So really, -6 minus -6 is -6 plus 6. And what do we get from that? 0. Okay. We need to do that for all of these data points. So -4 plus 6 is what? 2. Yeah, positive 2. -9 plus 6, -3. And the rest we've already done. So I'll just fill those in. Okay. So we've got our x minus x bar. What do we do next? Not square root. Square it. So take all these numbers and square them. Yeah, once we square them, we'll add them all up. So 0 squared is 0. 2 squared is 4. -3 squared is +9. Another 4, another 4, another +9. And remember, standard deviations cannot be negative. It's not possible because when we square them, we get rid of any possible negative numbers here. Okay, so now we sum them, add them all up. So let's see here, 0 plus 4 plus 9 plus 4 plus 4 plus 9 is 30. And then we need to divide that by n minus 1. So 30 divided by 5. So what is 30 divided by 5? 6. So our variance is 6. Again, all this stuff underneath the square root, that's our variance. Now once we actually go ahead and take that square root, it gives us our standard deviation. So now we're going to take the square root of 6, and that gives us 2.4. That's our standard deviation. Does that make sense? So again, the stuff underneath that square root is variance. Once we take the square root, it's standard deviation. All right, now range. Remember that range is a distance. It's the distance between the highest number and the lowest number. So what are my minimum and maximum numbers? -9 and -4. What is the distance between them? 5. Just 5, not -5 or anything like that, just 5, because distance cannot be negative. Excellent job. Okay, does that make sense? Any questions on this one? All right. Next, and the last one. Suppose that a company wishes to predict sales volume based on the amount of advertising expenditures. The sales manager thinks that the sales volume and advertising expenditures are modeled according to the following linear equation. Both sales volume and advertising expenditures are in thousands of dollars. That's important. That's extremely important. Okay? So the formula that it gives us, the linear equation, is estimated sales volume equals 47.58 plus 0.55 times advertising expenditures. And remember, both of these numbers right here, sales volume and advertising, are both in thousands of dollars. Okay? So if we put a number into one of these places, it needs to be converted into thousands of dollars. Okay, so it goes on to say, if the company has a target sales volume of $300,000, how much should the sales manager allocate for advertising in the budget? Round your answer to the nearest dollar. Okay, so again, what this is asking is, if we want to make $300,000, so that's our sales volume, how much do we need to spend on advertising? Now, like I said, it's in thousands of dollars, so we want to plug 300,000 in for here. So what are we actually going to plug in? Because it's not 300,000. This is $300,000. So again, this is $300,000. We want it to just be how many $1,000s we have. So how many thousands of dollars do we have? We have 300 of them, right? So that's what we're plugging in here is 300. Does that make sense?
Yeah, are the numbers 47.58 and 155, are those something guaranteed from?
No.
Okay.
They are constants. They will always be these numbers. These are the things that modify this in order to get this. So they will always be these numbers. There's nothing funky going on with them. Really what's going on with this question is it's trying to throw you a curveball by saying thousands of dollars. In a normal equation, you just plug a number into here and you get your value. But for whatever reason, this sales manager has put these in thousands of dollars, maybe to make it easier on himself and make a estimate instead of an exact value. Okay? So we're going to put 300,000 into here. I'm sorry, 300. that's how many $1,000 we want to make. And it's equal to 47.58 plus 0.55 times advertising expenditures, which I'm just going to call A. Now again, remember, advertising expenditures is also in thousands of dollars. So once we get this number, we're going to have to convert it back into a regular number like this. Just like we took this regular number and made it into a thousands of dollars thing, this is going to give us a thousands of dollars thing. We're going to have to convert it back to a normal number. But let's go ahead and solve. We need to get A by itself. So what's the first thing we should do? Do what?
Yeah.
Not add. Well, we can't add those because they're not like terms. Imagine this is x, this is 0.55x, and this is just a normal number. It's not an x value. So like this is telling us how many x's we have. This is just a number. We could divide. We would divide by 0.55 by the entire thing, but that means we also have to divide 47.58 by 0.55, and I'm feeling kind of lazy today. I don't want to do that. Yes. So we subtract this, and that will cancel because they are opposites. This one's positive, this one's negative. But in order to keep our balance on this equation, we need to also subtract 47.58 from this side. So let's see what we get there. 300 minus 47.58 gives us 252.42. Okay. Now we can divide. Now that we don't have this extra number on here, it's a lot easier to divide this thing off. Good. You'll find algebra in the weirdest places. Okay. So, again, multiplying by 0.55 and dividing by 0.55 are opposites, so they cancel. So let's see what we get here when we divide by 0.55. We get 458.945454545. I think you get the rest. It's repeating. So once again, we need to convert this back into a normal number, because this is telling us thousands of dollars. This is telling us 458 thousands of dollars. So if we want to convert this back into thousands, we multiply it by 1,000. So how many zeros are on 1,000? 3. So that's how many times we move this decimal. 1, 2, 3. And so our final rounded answer and everything is $458,945, which is bad news for them because they're going to be spending a lot more on advertising than they get in their sales volume. Excuse me? No, they probably need to fire their sales manager. Okay. Any questions? None? All right. So remember, this review is due Friday at midnight. Of course, you can turn it in any time before Friday at midnight. And I'd really prefer you do that, because what else happens Friday? Test. Now, what I would like, you don't have to do, but it'd be really nice if you did, is for you to turn this review in before you take the test. If you do that, then I can tell, okay, you've done the review, you have a good chance of getting a good score on the test. If you don't do the review until after you've done the test, then what's the point of the review, right? Okay, so the review is due by Friday at midnight, but it'd be really nice if you could get it turned in before you take that test. Okay? So any questions? Nope. Okay. Then in that case, I will see y'all on Friday, and I hope you have a good day.
You